Hi guys, this is Nilendu. Welcome to this tutorial on encapsulation. Encapsulation is one of the core concepts of OOPS. In fact, it is one of the four concepts of OOPS, which is abstraction, encapsulation, polymorphism, and inheritance. In the previous tutorial, we saw what is abstraction, and now in this tutorial, we will see what is encapsulation. So let's try to understand encapsulation with the help of one picture. So let's assume that this is a class and this class has some data members. If those data members can only be accessed by methods or function within that same class, that concept is called encapsulation. So to define it, we can say bundling of all the resources needed by an object to function properly within the same object is called encapsulation. Now let's see in a little bit more detail about encapsulation. So just to repeat what we mentioned in the previous slide. So whenever you keep the data and the methods which work on the data together, that concept is called encapsulation. So one of the benefits of encapsulation is your data is safe from manipulation from outside objects. The reason is since it can only be accessed by methods which are within the same class, so any other outside objects cannot change or modify the data. This also means that you can hide the implementation details from the outside object. So in future, if the implementation changes, the client of this class will need not bother like how the method is giving back the output based on the data in the class. They are going to be only bothered about that method returning the proper data type. That means if there is a complex algorithm to calculate something or solution to some problem, in future you can make it easier without the client objects needing to change. In Java, you can achieve encapsulation by making the data members and some of the methods private. What it means is you just add a private access modifier before you declare the data members and the methods. Now let's see an example of encapsulation. So here is a person class, and this class has age variable which is integer, and as you can see we have made it private. As soon as we make it private, this age variable or data member can only be accessed by methods which are over here or which are member of the person class. So age variable cannot be changed, or it will not be visible to any other class or method which is not in the person class. So these methods can access the age variable, whether they are public or private. As you can see, one of the methods is private, which is getAge. That means this method can be accessed only by methods which are within the person class, whereas these public methods, for example canDrive, canVote or setAge, can be accessed by outside objects also. So we are encapsulating the age, and whatever algorithm happens with the age variable within this person class is also encapsulated. So this is one of the examples of encapsulation. Now let's see an example of encapsulation in Java. So here is a person class with integer age and string name, both are private. That means they can be accessed by only methods within this person class. So setAge is a public method which can allow or which will allow outside objects to set the age of the person. CanDrive is another method, but it is also public. That means they can call this method to find out the age of the person. I'm sorry, they can call this method to find out whether this person can drive. So the logic here is if the age is greater than 16, then allow return true. That means this person can drive, else return false. That means if the person is less than 16, this person cannot drive. In future, if the rules changes for licensing and the minimum age becomes 18, still the outside objects will not be bothered about how this algorithm works. They will only want to know whether based on the current age of the person, can this person drive or not. So this is a very simple example of encapsulation. Now here is a very simple program. I think I made a mistake. I should have added a string argument or string array. So in case you want to try it out, please add a array over here of the string array. Anyway, so we are instantiating a person object and setting an age of 20, and now we can just simply call person1.canDrive. So this program will tell whether this person can drive or not based on the algorithm over here. So this program, test program, doesn't know how it is determined whether this person can drive. It is only bothered about that how, or is only bothered about knowing whether the person can drive based on the age which is being set in the person instance variable. Okay, now let's see what are the benefits. So as mentioned before, the major benefit is that implementation is hidden. So we can change the implementation without affecting the client. So client can still call canDrive method although the internal logic might have changed. So client will not be bothered how the logic has changed. They will just keep on calling the method and using that value in their further logic. It also encourages programming to interface. That means you can declare canDrive in the interface of the person, and all the clients only need to bother whether this person class has a canDrive method implemented or not. That's all. So you can design your interface and tell the outside client objects that these are the methods which I'm exposing and I will implement it, and I can also change the implementation in future, but you only need to bother about calling this method. So I can design a very interface which will be used by outside objects. It also prevents outside objects from changing the state of the object they are calling. So that means one object, if it wants to use the data member value of another object, it cannot directly call that data member. It has to call through public methods which are exposed by the other object. So that way the outside or the client object cannot change the data members or the state of the objects they are calling. Now Is there a situation where encapsulation may not fit? Yes, there is a situation. So suppose you want to write a test class for person, and you want to set, or you want to, you know, test a method which is private. You cannot do that from the test class. So what you need to do is you have to compromise there and make it protected. So whenever there is a choice between encapsulation and making it testable, you should go or lean towards making it testable, and second choice would be encapsulation. So there are situations wherein you may need to forego the private access modifier and make it protected so that they can be accessed by the test classes which are going to test the class uh, in class which is being uh, tested. So that's all we had in encapsulation. Thank you for watching my video, and in case you have liked it, so please like my video or leave your comment in the section below, and I hope you come back and watch the future series also. Thank you.